Using laser devices to control the planet's weather is the stuff of megalomaniacal comic book supervillains. But scientists have shown they can use lasers to disrupt crystals of ice which form in the upper atmosphere, causing them to shatter. According to the team, the smaller fragments could increase the amount of light and heat being reflected back into space by the upper atmosphere, having a cooling effect on the climate. High up in Earth's atmosphere, between 6 to 12 kilometers, ice crystals form cirrus clouds which affect how reflective the planet is. A team led by researchers at the University of Geneva recreated these atmospheric ice-forming conditions in the lab, creating tiny chunks of ice just 90 micrometers in width. When these tiny crystals were zapped with bursts of laser energy, it created a tiny ball of plasma inside them, which caused the ice to vaporize. This vaporization also generated a shock wave, causing the ice balls to explode and shatter into tiny pieces, multiplying the ice shards in the atmosphere. In effect, zapping the ice crystals generates a dusting of far smaller particles, transforming a single large reflective object into a fine dust of reflective material. The researchers believe the approach could be used to boost the reflective index, or albedo, of the upper atmosphere, causing more of the sun's energy to be reflected back into space and tweaking the planet's climate. Writing in the journal Science Advances, the authors explain, "Our results open prospects to modifying the particle size distribution and, thus, the albedo of cirrus ice particle clouds." Scientists believe the approach could offer a promising method for manipulating the weather and studying climate. Lasers could be used as a targeted means for cloud seeding, ice formation and, as the Swiss team demonstrated, boosting the reflectiveness of atmosphere. Some researchers have suggested that contrails, left by planes in the upper atmosphere, could have an effect on the climate by interfering with the ice-forming process and the atmosphere's albedo. Water vapor from aircraft exhaust forms ice crystals, which opponents have argued is an unintentional form of geoengineering. However, the evidence is inconclusive. Research by the Geneva Group in 2013 showed the approach of ice multiplication was possible in the lab, but its latest study used high-speed cameras shooting 140,000 frames per second to show direct observations of the process. While the real-world application of the approach using lasers is still some way off, technological advances could mean weather rays could one day be commonplace. Dr. Mary Matthews, a researcher at the University of Geneva and first author of the study, told Science News, "What we are hoping for is that the advances in laser technology, which are moving faster and faster all the time, will enable high-powered, mobile lasers,